the room quiet. My name is David Lewis. I'm the Dean of the School of Constructed Environments here at Parsons, and I welcome you tonight for this really exciting event and for tonight's panel focused on hemp. This is the fourth event in the From Field to Form series organized by the Architecture League. In part, and this is going to be a shameless plug, catalyzed by LTL's publication, the publication of my firm, of which I'm a principal. That's the book. And initiated by Rosalie Ginevro, this series brings together a range of experts, from growers to manufacturers, architects to builders, who are working with biogenic and geogenic materials with the goal of expanding their uses to address climate change, biodiversity, and the human health consequences of our current industrialized building systems. Some questions to be addressed. What new building materials and assembly techniques are emerging? What are the bottlenecks in growing, manufacturing, code, assembly, cost, supply chains, marketing, as well as perception? What are the intriguing architectural consequences of these materials? What changes occur to the design process when the scope of a building expands to include the fields that grow its form? The three previous From Field to Form events provided an introduction focused on stone and on earth. And today, we turn to hemp. We are indebted for this event to the work of the Architecture League, Anne Rieselbach, Jacob Moore, and Zoe Fruchter, and the support of its members. We're indebted also to the staff of the School of Constructed Environments here at Parsons, with specific thanks to Lena Shoei, and supported in part by the public funds from the New York State Council on the Arts, with the support of the Office of the Governor and the New York State Legislature. Tonight's edition is co-presented and co-hosted by the Healthy Materials Lab at Parsons, and I'm pleased to introduce the founding directors, Alison, Mears, and Jonsara, Ruth, to begin our conversation. They are also faculty at the School of Constructed Environments. Jonsara and Alison.
Thank you, David. Thank you, Dean David Lewis, and also founding principal of LTL, for all of your help collaborating on this. Hemp is the future. And thank you to all at the Architecture League for collaborating with us on this event. It's been really fun to prepare this program for you all. All the names that David just mentioned, like Jacob and Anne and Zoe and Alicia, thank you. Also, thanks to LTL for writing this book. This Manual of Biogenic House Sections, what has sparked so much curiosity and energy behind plants to be the next buildings. Who are you? So I am Jonsara.
I'm Alison. We co-direct Healthy Materials Lab,
which we founded in 2025 here at Parsons, with specifically to put human and environmental health at the center of every design decision. I'm a designer.
I'm an architect.
And we and our amazing team are invested in a future where all people and the planet will thrive, and charting pathways to get us there. So I think we have a short presentation just to give an overview of hemp and building. And I think I'll start us off, and then I'll hand it over to Alison. So in our search to build healthy, affordable homes, we discovered hemp lime about 6 years ago. Contemporary affordable homes are primarily constructed of products made from petrochemicals. And these petrochemical-based products use a vast array of untested toxic chemicals that consume and emit carbon. And the places where those products are made are polluting water, air, and earth. that we rely upon to survive. This is the basis of our building products today. It's now a known fact that those materials in buildings, in cities, in objects, in furniture are releasing toxic particles that are absorbed into all of our bodies. We might assume, and most of us do assume, that the products and materials that we buy are tested for safety. Of course, we're protected by law, right? Not really. Most of the chemicals commonly used in building and consumer products today in the United States are not regulated for their impact on human health or on the environment. In fact, only 250 of the more than 80,000 chemicals currently in use are tested, and only 5 have been partially restricted by law, which puts it on us as architects and designers to make better decisions. This is a chromatogram from our research partner at New York City, Mount Sinai's Institute for Exposomic Research. And this reveals that there are millions of industrial chemicals found in the blood of all of us. These are the same chemicals that trigger many of the diseases that harm us today, from cancers to diabetes, and the list is long. So, if we look at a typical residential wall system in the United States, for example, there are many layers of building products, which in each layer often contains a toxic chemical. In our work, we're eager for these building systems to be healthier and also to become the norm, which is why we're here today and why we're very excited. Because we are at an inflection point. We are in an era where we cannot continue to build in the same way that Western civilization has been developing. So at Healthy Materials Lab, we ask, what is the pathway forward? How can we design and build healthy, affordable buildings today? At Healthy Materials Lab, we address the toxics and climate issue by charting new pathways to design and build healthy buildings. This is our small and mighty team, really an incredible team of dedicated researchers and colleagues who are all together working collaboratively toward bringing awareness and change to our industry. At Healthy Materials Lab, we look at the ingredients of materials and how they impact humans, ecosystems, and all species throughout their life cycle, from raw material extraction through production, transportation, into product development, and then into installation. Of course, in use, in maintenance, and then to recycling or disposal. And in each case, we know that the first step to understanding if a material is healthier or not is seeking transparency, learning the ingredients of every particular product. A manufacturer must reveal those ingredients, and then we have to go through an analysis to understand which of those ingredients are benign or which are negatively impactful. So you may have heard of a health product declaration, an HPD, or a declare label. But we're impatient. These declarations are similar to nutrition labels on food packages. So removing toxic ingredients and finding benign substitutions is a worthy next step. But what if, instead of sifting through these lists of chemicals and figuring out what's bad and what's good and removing the bad and keeping the good, what if simply we ask if a material starts with good ingredients? We don't have to go through this whole analysis. So this is how we landed at Hemp Lime. Our healthy materials research began in 2017 looking at this hemp lime because it's made of 3 ingredients: hemp from the hemp plant, lime from the limestone, and a little bit of water. The ingredients contain no toxic chemicals, they're biodegradable, creating no waste, and the main ingredient, the hemp plant, is regenerative. There's a long list of attributes. As a matrix, it has these qualities that help create a nature-positive building. It's recyclable and biodegradable. It regulates humidity and climate indoors. It absorbs carbon from the atmosphere as it dries and as it continues to live in its building. It's thermally efficient. It's fire, mold, and pest resistant naturally without added chemicals. And it lasts a very long time. As an insulation, hemp lime is incredibly energy efficient from its production through its use to its disposal or reuse. We mapped the system that would need to be created in order to make hemp lime a viable industry in the United States. So this diagram looks at the complexity of launching an agricultural, plant, mineral-based materials ecosystem that creates the new ingredients for buildings. We embarked on research about the history of hemp in North America. It's been cultivated and used by indigenous nations long before colonizers reached the Americas. Alex White Plume in South Dakota and others like Winona LaDuke and Earl Pendleton in Minnesota have been advocating, cultivating, and using hemp long before its recent legalization, and working on innovative production models to provide markets for hemp crops. We visited Winona LaDuke's hemp farm to learn how the people of White Earth are establishing a new cooperative hemp industry with other local indigenous leaders. Early in American history, it's important to remember that essential knowledge about how to work with the tough hemp plant was embodied in enslaved people. After emancipation, this knowledge was mostly lost.
Do a little dance here. I don't think I can do that. Thanks. In 2019, we visited farms in New York, Pennsylvania, Kentucky, and in Italy to understand how agriculture could create a new supply chain for the building industry. We spoke to farmers who were successful in harvesting a healthy crop of hemp, but because there were very few decortication facilities available, there was no market for their crop. We visited limestone quarries around the world to learn how cultures have been using lime for centuries and how lime could be used today. In Italy, we visited architects, Pedone Working, who've been building super insulated single and multifamily social housing using hemp lime for over a decade, because hemp has always been legal to grow there. We visited places in Europe like Hemp in Belgium, where they're manufacturing precast hemp lime blocks and panels in large quantities. We think about a revival of vocational training for masons and plasterers to lay hemp blocks and plaster new walls as part of workforce development in the US. We brought back some knowledge gained through our visits in Europe and worked with Anna and Drew at Coexist in Pennsylvania to produce 1,000 hemp lime blocks. One of them is right over there. After all that research, we wanted to implement and test hemp lime building in the US. Because renovation has a much lower carbon footprint than new construction, and because there are many abandoned wood houses and communities across the US. We collaborated with a group on a pilot project to renovate a house in Newcastle, Pennsylvania, led by community housing provider Don Services. The project was funded by the Pennsylvania Department of Agriculture. The house used a blown hemp lime insulation system, so it was pretty quick to install, taking about 2.5 days to fully pack the walls. This is Cameron McIntosh checking on the work there as he does. We worked with manufacturers of healthier products to donate healthier finished materials to reduce the toxic emissions indoors, because it's not enough to create this amazing natural frame to the building, but everything you put into it has to be toxic free. So after the opening, we conducted indoor air quality testing and identified a 400% reduction in formaldehyde compared to a similar sized control house made from conventional materials. At the start of the design construction process, there was no guidance in the local building code for hemp lime construction, which slowed the filing process. The PA Hemp Home was used as an example and supported documentation for the proposed hemp lime construction appendix to the upcoming 2024 International Residential Code. This project has led us to contact a handful of other architects and builders around the world to learn from their experience, to look at scale, to look at implementation, to look at detailing, to look at installation. Our initial research, as well as our subsequent case studies, are downloadable for free from our website. It's a thing we do for free, right? Today, and I think that we'll hear more about this, although there are farms planting hemp across the United States, hemp cultivation has declined while the industry awaits guidance from the federal government on the regulation and use of hemp products. Today, hemp acreage is small, just slightly larger than the area used to grow Christmas trees. While there's a huge value from hemp-derived CBD products, the demand and value of hemp hurd is low. In contrast, there is a countrywide access to limestone and processing to create lime products. We see building homes as central to our ability to make change. Through the building of healthy, affordable housing, we can start not only building a demand for hemp-based products, but we can also address toxics, carbon, equity, and loss of biodiversity issues. And as we improve materials for buildings and building systems, we also encourage economic development, workforce development, profitable agricultural systems, new materials, and product development, all of which supports healthier lives.
So this work, passing the hemp baton, this work and the deep thought, it requires a lot of deep thought and wisdom from all of us, and we are so excited to connect with the deep wisdom and expertise of our guests tonight as we look at the fully functional hemp ecosystem. This knowledge is essential to making this change, and I'm looking at the three of you because you're at the forefront. Thank you for coming tonight. We just, have a quick commercial break because yesterday we got a call, actually Monday, we got a call from the U.S. Hemp Building Association who said, please, can we talk before you have this event? So we talked with them yesterday for a few minutes, and they wanted us to tell you that in addition to hemp lime being accepted into the International Residential Code starting this next year, 2024, they are creating a model spec for hemp lime to be used in commercial buildings. And this will be available in 2024 on their website. You can find more additional technical information so that you can all build with hemp lime at www.ushempbuildingassociation.org. And they really encourage you to go there because they want this all to happen soon. So without much further delay, we are thrilled to introduce the speakers tonight. Well, I'll introduce all three so that they can just come up in continuous, and then we will engage them in a conversation and engage you in a conversation about how we make this hemp lime this hemp ecosystem for real, how we can make this really happen in the United States. So first, I'll introduce Larry Smart, who I had the pleasure of visiting in his laboratory on Monday. Larry is a plant geneticist and breeder who uses genomic tools to understand plant biology and to breed improved cultivars of three crops: hemp for grain, fiber, and cannabinoids, shrub willow for bioenergy and carbon sequestration, and hop for craft breweries in New York. Some people might be interested in that. His research focuses on hybrid vigor, sex determination, and disease resistance in plants. He earned a Bachelor of Science in Biology from Cornell University, a PhD in Genetics from Michigan State University, and he was a National Science Foundation postdoctoral fellow at UC Davis. He's been a professor at Cornell Agricultural Tech in Geneva, New York since 2009, and has been leading the Cornell Hemp Research and Extension team since 2017. Larry, thank you so much for coming. It's awesome. So I'll skip to the next speaker, who's we're also very excited to have here. Tommy Gibbons is the Chief Innovation Officer at Hempitecture, a public benefit corporation created to develop, manufacture, and distribute sustainable, high-performing building materials. Tommy is also an Innovator Fellow with the DOE's Building Technology Office at Oak Ridge National Laboratory to facilitate Hempitecture's product development. Before Hempitecture, Tommy worked in growth operations at Piper Learning in San Francisco and investment banking at Goldman Sachs, so he's really going to make this whole thing work. He's also a lead green associate at Department of Energy Impel Innovator and is certified by the French L'École Nationale du Chanvre, because the French really know how to grow their hemp. He graduated from Princeton University in 2013 with a degree in public policy. We vote for you, Tommy. And finally, Jennifer Martin is a sustainable design builder with so much spirit and over 20 years of experience in natural building materials and systems. For over a decade, Jennifer was steeped in natural building at Dancing Rabbit Eco Village in Rutledge, Missouri, where she utilized local materials to design and build village-scale infrastructure. Jennifer has experience in LEED Platinum, Living Building Challenge, and Passive House building methodologies, and since 2019 puts this extensive experience in natural building and ecological design to use at HempStone. HempStone was established with her building partner, Tom Rossmassler, and it's based in New England, in Massachusetts, providing full-service hempcrete design and construction services, and supports the development of carbon-beneficial construction. They are regional leaders of the U.S. Hemp Building Association, and they are helping to establish the hemp building industry in the U.S. HempStone has had the opportunity to learn from and work alongside several key international leaders in the hempcrete movement. Jennifer serves as design consultant, construction manager, and professional educator of hempcrete or hemp lime and natural plaster, and has been principally involved in over a dozen hempcrete builds in the United States. Most recently, Jennifer has been working with the Lower Sioux tribe to help them grow their hemp lime building ecosystem. We're so thrilled that you all made time to be with us tonight, and we'll hand it over to you. Thanks so much.
On your relationship with the custodian. Well, thanks very much for that generous introduction. My name's Larry Smart. I'm a professor in the School of Integrated Plant Science at Cornell University. I am based at Cornell Agritech, which is our campus in Geneva, New York. I'm a plant breeder, and I'm going to give you a quick overview of hemp as a crop, including how to harvest it and a little bit about how to process it before we lead into the real expert who will follow me. So I always like to start my talks to a general audience in describing the difference between hemp and high THC cannabis. And it's really a legal difference. Botanically, there's no difference. Biochemically, there's really only a difference in one compound, and that's THC. So this plant has been defined by a legal test for THC content. Hemp is defined as having less than 0.3% THC. High THC cannabis exceeds that 0.3 limit. We do have hemp cultivars that if you let them grow to a certain point, they will exceed that 0.3 limit, and one day they're hemp, and legally the next day they're high THC cannabis. But there are ways to get around that. The laws are very squishy here. Hemp became legal largely through the actions of Leader McConnell at the time. So in the 2014 Farm Bill, hemp it became possible to grow hemp under what they called state pilot programs, but really it was the 2018 Farm Bill that, again, Senator Schumer and McConnell championed, removing hemp from the Schedule 1 controlled substance list. So from 1970 until 2018, hemp was classified as a Schedule 1 drug, the same as heroin. That hemp seed that I brought here that's sitting on the table, prior to 2018, I needed a DEA registration to hold that hemp seed as if it was heroin. So really, the floodgates opened through the actions of the 2018 Farm Bill to remove hemp from the controlled substance list. And within a year, essentially every state, well, not every state, but many of the states in the country, Idaho was a holdout, many states in the country developed programs to cultivate hemp. And we grow hemp for 3 different markets, primarily for the cannabinoids, mainly CBD. That is an intensive horticultural operation, either outdoors or indoors. But we're here to talk about fiber hemp and the bast and hurd. We can also grow hemp for a very nutritious, whether it's for human food or animal food, a nutritious grain product. So how do you plant hemp? Well, in this case, we're planting hemp like we would plant any other row crop, we call it. Wheat, corn. We use a conventional grain drill, so we are preparing the land here. In this case, this was a full tillage operation. We can no-till hemp in certain areas of the country. That helps with water conservation, but really it's a pretty conventional agricultural crop. The problem is that in the absence of all of the research and commercial activity around hemp prior to the 2018 Farm Bill, we don't have many of the tools that farmers rely on for successful cultivation. And farming is very risky. One of the main risks that they face is competition from weeds. So we right now only have one herbicide that can legally be used to control weeds in hemp, and that's just not enough. So if you don't prepare your field well, if you have a heavy weed seed bed, this is Don Spoth, one of our farmers in Western New York, who did a pretty good job with this field, but you can see how uneven it was established. If you don't control those weeds, you end up with something like this, a field that's only 2 feet tall, and you have trouble picking out the hemp from all the weeds. So we need to build up not only that knowledge base, but also supply farmers with the tools that they need to de-risk the cultivation of hemp. If you do get good establishment and have proper water and temperature early on, hemp grows incredibly quickly in the month of July. Inches per day, potentially. Very rapid mid-season growth, and that way it can close canopy and compete out the other weeds. So this is what we're looking for in the middle of July, and then by the end of the season in September, we are breeding fiber varieties that flower very late in the season, and that's what gives us the tallest growth. So these stems are from our research trials, 12 feet tall at the end of the season. That's what we need to get the highest yield of fiber hemp. The next trick then is, how do you harvest this stuff that's 12 feet tall? Well, we do have machines. This was a machine that was designed in the Netherlands to harvest both the grain from a very tall, 12-foot tall plant. So that grain harvesting combine, they devised a mechanism to get it up to 6 feet tall, where normally it would ride just a few inches above the ground. And then that red machine at the bottom is cutting the stems at the base and chopping the stems into 20-inch pieces to capture both the fiber and the grain, so a dual-purpose harvest. But we often will want to harvest simply for the fiber. And it's actually relatively simple to harvest those stems for fiber. You cut them with a sickle bar, so that's a very simple mower. Can go very fast through the field. And again, to make things easier downstream in terms of baling and processing the stems, This company in Nebraska has devised a harvester with 4 sickle bars that are spaced 30 inches apart. So you're chopping this 12-foot tall stem into a bunch of 30-inch pieces. The next tricky step is retting. So after you've cut the stems, you need to leave them on the field, and during that time, usually about 2 to 3 weeks, the stem effectively rots. Retting, I'm told, is the Dutch term for rotting. And I brought a bunch of retted stems here with me. You can play around with them maybe later. And the key here is that we need to separate the long, strong fibers on the outside of the stem from the inner woody hurd. And you can see in the picture on the left, those bright pink cells on the outer layer of the stem. That is the long fiber that we have used historically to make textiles, to make rope, to make sailcloth for the British Navy. The tricky thing is you want to separate those long fibers from the inner woody hurd, which is what we're going to use for the hemp line. So this has been properly retted, and I'm going through the process of decorticating this stem and separating the fiber from the hurd. So we have hurd for hemp lime. We have fiber that can have multiple applications, but historically has been used for textiles and rope and sailcloth. And you can play with it and feel how durable that stuff is. But the whole key to getting those two things separated is the retting. So I just decorticated by hand, but we need to develop machinery to do that efficiently. This is a machine that was built by a startup company in Colorado called Formation Ag. This is our mobile decorticator that we have at Cornell. The first black box there on the right side is a bale unwinder. So we're going to put an entire bale of hemp straw in there. It will unwind that and feed it through these 6 sets of rollers that are crushing in a progressively more aggressive manner, crushing the stem to do this separation of fiber from hurd. And then the next step is to separate those materials effectively and clean them, get the dust away, get the hurd, any remaining hurd, away from the fiber, so that that basic processing company can deliver what the product company needs. So what does Hempitecture need? They're going to define, we need this level of clean fiber with no hurd, or we need hurd with no dust for making hemp lime. And it's a tricky and dusty and dirty process of doing all this separation based on size and material properties. I think I need to wrap up here. But I just want to put one more pitch that what we need in this industry is, and whatever every farmer is looking for, is cultivars that perform well in their environment. And that means are easy to establish, give them high yield, and are attractive to the buyer. So as a plant breeder, we look to our consumers, our processors, and our consumers as to what characteristics do you need. We work with farmers. Obviously, yield is important. And we work to develop those cultivars that are going to be widely adopted in the industry. And I think we are being successful in that. And this is a new cultivar that we are releasing commercially under the trademark Ursa, which is the genus of bear. That's our mascot at Cornell. And this tall, 12-foot tall fiber variety will be called Alta. So we have trialed this together with academic colleagues at University of Kentucky, North Carolina State, Texas A&M, and University of Florida. You can see that we get the highest yields at our high latitude in New York State. And at least in initial trials, we're producing 8 tons of retted straw per acre. Pretty much the industry an excellent yield in the industry right now would be 4 tons. I would say the average is probably 2 to 3 tons. So if we can come up with a cultivar that will double yield, that will have a huge impact on the industry. And we think we're close to that. None of this would have been possible without very strong support from New York State. So thank you to the taxpayers of New York. Support through Department of Agriculture and Markets, Empire State Development, and the Office of Cannabis Management, as well as federal funding matched by industry funding from the Foundation for Food and Agriculture Research. And what we need in this industry, and these are the people I love working with, are pioneers like Corbett at Formation Ag and Global Fiber Processing, and Maddie and Tommy at Hempitecture. So hopefully that's a segue to the next phase of this discussion, and Tommy Gibbons.
Wow, great presentation. Yep, that is me in the top right, like a Minecraft pixelated version of myself, but you got to use your own materials if other people are going to buy them. You got to know what they're getting into. Awesome. So thank you again. I know you guys aren't here to hear thank yous. You're here to hear about hemp building. So thank you so much for just being here, and thank you for organizing. This feels like a really big step in moving the industry forward. You guys are the ears we've been trying to get in for so long. It's been fringe. Jennifer's been there right with me when we were in hempcrete kumbaya type sessions in a very narrow field. I wouldn't say we're mainstream yet, but we're probably avant-garde. So congratulations to all you guys for being leaders and pioneers, and you're going to leave this room with a top 1% knowledge of what this industry is all about, and you're going to be able to educate others. And so I can feel the exponential growth. So my name is Tommy. I'm a co-founder, chief innovation officer, which is probably a purposely nebulous title, at Hempitecture. And at Hempitecture, we are a manufacturer and distributor of these building products. So these products no longer exist in just a concept form or something you'd read about in Europe, or could find more information online but couldn't really find in practice. These are being installed in homes every day, delivered to job sites, sitting in warehouses, in subcontractors' hands. It's a really, really awesome time to be in this industry. And I'm not a farmer. I'm not a builder. I'm an entrepreneur, I guess I would say, with a little bit of dalliance in all those fields that can help bring it together. And you guys will see all the pieces that are in play when it comes to not just creating a new product, but really a new industry. So why do we even need a new insulation product? I think that's kind of a good place to start. Like you guys know, there's fiberglass probably in these walls, mineral wool, spray foam. All of these are effective insulations at doing something, right? Why do we need to reinvent something with hemp all of a sudden? Are we just hempsters trying to get hemp proliferated for hemp's sake? Well, no, not really. And you guys should know that better than anyone. Green building has taken on a very new and important definition. It is no longer just about operational efficiency. It is about what constitutes the materials that actually go inside your building. And that's a very, very important distinction, because there's a lot of really high-performing materials out there that are made of absolutely rotten ingredients or chemicals or petrochemicals or treatments added to the materials. And so it's taking a more holistic view of our supply chains and materials, not just what is the effect when they're inside the wall, but what has to happen to get these materials to the job sites and into builders' hands. And so that's our raison d'etre, is we are insulation with a totally different spin on embodied carbon. And here we go. That's just another illustration of what that really means, right? Operational is during the useful life of the building. How much energy does it take and consume? Do you have high performance windows? Do you have solar as your energy source? Versus embodied carbon is, what is the summation of all of the greenhouse gas emissions to produce these materials and get them to your job site? Because maybe you're using a really low embodied carbon material, but it's coming from Australia or India, and so it has to take a high embodied carbon route to you. Whereas if there's locally sourced mineral wool or fiberglass, maybe that is a better trade-off. So it's really taking a new lens to all the building materials and putting them through that scope of what is the summation of energy and carbon and greenhouse gas emissions to produce this material. So that's what we believe. In order to really take a step forward in green building, we need to take that lens of what are the entire life cycle analyses of our products. We need to use that environmental product declaration, nutrition label to compare these, get as close to apples. And you guys all know this. You see the industry is moving in this direction, really taking a close microscopic view as to who are these suppliers, what is the transparency that they have inside of them, where are these materials coming from, and then how is the performance and testing validated. So that's us. We are a bio-based building materials manufacturer. We specialize in using industrial hemp. Why? Because it's got an amazing profile for sustainability. Not just the fact that it takes, low pesticides, low fertilizers, low water usage to grow the plant, but it actually has the potential to sequester a huge amount of carbon during its growth cycle, right? We learned that in biology in 3rd or 4th grade. If plants take sunlight, right, they synthesize the ATP, and then they respire oxygen and sequester carbon. And that is a magical process that we can harness at scale. So what is that number? Right now, this is using European data because a lot of the American data is still just coming out here. We're all so new in this industry. It's roughly 9 tons of CO2 can be sequestered per acre. I mean, we're looking at yield of 8 tons. So almost that entire weight of that plant plus some is sequestered carbon. It is truly biogenic carbon, which is the most naturally produced in its rawest form, which is a very beautiful thing. So how do we turn this plant fiber and these fibers here into a usable insulation product? Well, we are very transparent about how we do this. So you could go on YouTube and you can see our line running. You can see people taking tours of our factory. But basically, to simplify it is, you take the fiber in a baled form and you're basically brushing it. Like you're combing the fibers, you're creating a nice homogeneous length of fiber, distribution of weight inside the fiber. You're hopefully separating out that herd. A big point you'll hear is hempcrete builders or hemp line builders don't like to have fiber in their herd. Hemp fiber producers like ourselves don't like to have herd in our fiber, right? So you definitely want to keep them separated. You take that 90% hemp fiber by weight, you add a little bit of textile polyester, which acts as the glue. You put it through a sequential pneumatic line. You blend it all together. Pneumatic, I mean air propelled. And then it goes into this airlay former. So it's basically put into one big sheet of hemp, and you can almost see it. Well, that would be the oven it's coming out of. And then it's set. And to set it, you actually put it through an oven, and that melts the textile polyester, bonds all of the hemp fibers together, and so you have a very strong, rigid insulation mat that can be sized to 16-inch on center, 24-inch on center, can come in various depths, 2 inches, 3.5 inches, 5.5, 7.5 inches. Just basically the same exact form factor you'd expect from fiberglass or mineral wool if you were to walk into Home Depot or Lowe's. And we actually have samples over there if you'd like to take them. So we focus on a product that is in every building, which we view as having a huge impact and potential for scale, which is insulation. And we're very, very lucky to really be in a renewed focus and interest in insulation. If you guys have talked to clients who are interested in retrofitting about the Inflation Reduction Act and the 10 years of tax credits, the 25C energy efficiency upgrades that you can get, we're talking to customers about that every day. It's basically like what the EV industry got for electric cars, we now have for insulation. So we are very much honed in on how can we get as much high-performing insulation out to the market over the next 10 years. But we actually go beyond just insulation products. So you'll see hemp wool is our second one there from the left. Plant panel is a continuous insulation board. That's probably something you've noticed is becoming more and more popular. Continuous insulation eliminates any thermal bridging that could, heat passing through the studs or the less insulating members of your wall assembly, giving you one big monolithic surface of insulation. We also have a loose fill insulation product that I'm going to talk a little bit more about because it's very serendipitous that I'm announcing it here. And then Plant Pad, which is a carpet underlayment product. So if you're living in the city, you know how noisy cats and neighbors can be from apartment to apartment. So it's a carpet underlayment product to reduce sound transmission through ceilings. And then Acoustabat is same product concept. It's just particularly for interior walls, a little higher density, a little better sound insulation performance. And then, I'll talk about our taglines, right? So we're using bio-based fire retardants. There's no itch. It's easy to touch, easy to install, which you can't just have a better product that's not easy to install. We learned that kind of the hard way. Here's an example of a climate enclosure we have, and so we're using both our plant panel as well as our hemp wool cavity bat insulation. We like to push people in this direction because I think it's a really solid wall assembly that'll work in a lot of different climate zones. You're achieving really high performance because you're having 2 layers in instances of insulation. You have that monolithic insulator, eliminating thermal bridging, and then there's actually an interior vapor retarder just to make sure you have a wall cavity that is not getting any excess humidity or moisture inside of it. And then there's actually even a 3rd layer of insulation going perpendicular to the cavity insulation before you get to your drywall. So a lot of options. How much insulation in each wall is always a function of how much the client wants to spend, what their climate zone is, and really what's available. So we are transforming this experience of insulation. I think you guys probably, it's funny, I think before we started manufacturing this product ourselves, we were a reseller. So we established the United States market by reselling an imported French-Canadian product. And that product was actually manufactured in a town, ironically enough, called Asbestos, Quebec. It was named for the world's largest asbestos mine. Asbestos was outlawed in Canada in 1990, but they continued to manufacture it and export it to India until 2012. It's quite sad, actually. They had to move the town 4 times as the mine got bigger. They just kept moving the town as the pit grew and grew. And so eventually this town said, okay, you're shutting down asbestos for us. What can we do that's potentially sustainable? In some type of poetic justice, they did get the first non-wovens natural fiber hemp insulation facility in North America. And it just shows how far we've come, right? What do we want our environments and the habitats that our installers have to go through, right? And here you see someone who's wearing a complete hazmat suit or a near hazmat suit to install their product. Someone who's maybe got fiberglass or mineral wool fibers in their eyes, or someone who's itched to the touch. If you ever spent a summer installing insulation on a job site, you know how easily that can happen. And contrast that with our products, right? You've got, that guy was a surfer. He'd never built anything in his life, and he got our product, and now suddenly he's sticking it in the walls. And then up there's a dog on it, and then you have a family installing the product. Like, this is putting the tools of building back into people's hands. It's not saying, hey, you need a spray foam rig to build your own house. It's, if you've got hands and maybe a dust mask, then you can start insulating your own walls. We actually don't just do insulation and building materials. This may not be as interesting to a room of architects, but we do, that Hello Fresh package, cold freight packaging is what it's called. Same principles as a house. You want to keep the inside climate controlled. We also do mattress toppers. People are looking for organic mattress materials or US made mattress products. It's a very similar concept and product form. This slide, this is not our pitch deck, but I just talked about our investment partners. We are lucky to have Cornell as a sponsor of ours because we won the Grow New York Award, which is part of the reason why I live in New York City now. We funded ourselves. We built the first American hemp insulation facility using crowdsourced funds. So we have investors from as little as $100 putting money towards our growth and development. That's something we're very proud of and potentially could do again. So if you're interested in being a partner, I would say sign up for our email list because you might hear some good news soon. And then lastly, NYSERDA. So you guys, thank you all if you're New York residents. I know some people are traveling to get here. That's amazing. If you guys have paid that little NYSERDA surcharge, you are supporting this industry because just this Monday, we signed an agreement with NYSERDA to develop a loose fill blow-in insulation product made of hemp fiber grown in New York State. So that is, I was actually in this room when I heard about the opportunity, about last year I think it was. We had the NYSERDA crew here, and I said, you know what, that's what we're here to do. I think I was back home visiting family. I wasn't even supposed to be in New York. And we applied, and after a year of contract negotiations, we've come to terms. And so hopefully 2025, we'll be producing loose fill insulation as well as our bat and board products in the United States. And then Onyx is a modular sustainable home builder. They were the lead of our equity crowdfunding round. And that just shows you, yeah, there's DIYers, there's people who are insulating vans or small tiny homes or just sound recording studio rooms with our products, but there's also the other side of the scale. There's McMansions on Palms Boulevard in Venice, California. There's home builders who are doing this at scale and production style building who are using our product. And the range, people say, where does your product usually end up? And I'm like, everywhere. Commercial, personal, it has applications anywhere you're really trying to control the environment and climate of a room. And then we wouldn't be here today without really our incredible team. I mean, I'm just one person. Luckily, I get to be the face at times and represent all the amazing things we do, but there is a whole cast of characters today that was working the installation line, sending out our customer emails, moving trucks from one place to another, answering information that could have easily been answered just by a website scroll. But people like to call us, so we answer the phone. And it's really an awesome team that has put the energy behind this to make these products available to people across the United States. And that was our goal. You know, I digressed to explain exactly how I got in this role. I mean, you said I was working in children computer startups and then investment banking in my past. There was certainly no career tent that I went to that said, get involved in hemp building. It was a winding and serendipitous path, but it was actually something very similar to how you guys started here. I showed up to a room and someone started talking about these materials, and I saw the interest, and I said, I want to make my job making these materials available for everybody. I don't want to just build a tiny house for myself. I want to make these products available because I see a future and a lot of potential here. So I know we're going to have a great discussion of Q&A. Any questions you have, send to our moderators, send to us, talk to us after. This is going to be a really fun discussion, so thank you guys for listening. Next up is Jennifer from HempStone.
Hi, everyone. Wow, this is a great big room with lots of people. It's so nice to see all your shiny faces. Wow, can y'all hear me okay? Kind of in between. Okay. My name is Jennifer Martin. I'm a sustainable design builder, and I've worked almost exclusively with natural building materials for the last 25 years. My enthusiasm for lime plaster is what brought me to hemp lime/hempcrete. I'm going to use the phrase hempcrete in place of hemp lime because that's what I'm used to using, so you've been warned. I began working with hempcrete 4 years ago when I partnered with Tom Ross-Massler at HempStone. Together, we have studied under many international leaders in hempcrete and have been principally involved in 15 hempcrete projects in the United States. The U.S. hemp building industry is nascent. Our dedication to hempcrete in the early stage requires us to be involved in nearly every aspect of the building process. My roles at HempStone include on-site education, design and construction consultation, project management, and product development. We partner vigorously with others in the hemp building industry to meet clients' needs using hemp and lime as primary building materials. Rather than relying on a single hempcrete product or installation method, we engage all available and burgeoning options using hemp and lime. I feel rather privileged tonight. The Healthy Materials Lab has published what I believe is our nation's current best information on hempcrete, and these resources are sure to inform and inspire. Their first publication, Hemp and Lime, provides a solid foundation in these materials, while Designing with Hemp and Lime serves as a companion guide, providing construction and design details of 6 hempcrete builds from around the world. I was fortunate to be principally involved in 2 of these builds, Wally Farms in the Hudson Valley region of New York and the Cape Cod Hemp Home on the coast of Massachusetts. I encourage you to investigate these excellent resources. In the meantime, let's delve into some hempcrete basics. Hempcrete is a biocomposite made of the inner woody core of the industrial hemp plant. These cute little things right here. Combined with a lime-based binder, which is comprised primarily of calcium carbonate or limestone. And water is our third ingredient. These materials are mixed together. The lime coats and bonds to each piece of hemp, and the water reacts with the lime, causing the lime to begin absorbing carbon dioxide and hardening back into limestone. This creates a lightweight, moist material that is ready to be packed or placed into a form, creating an insulative walling mass. Hempcrete can be installed anywhere in the thermal envelope as long as it's isolated from groundwater. Here you see hempcrete in a floor, wall, and roof, making the material very adaptable as an insulated walling mass. While the material dries into a final solid mass, it is not structural itself. The material requires a structural frame. Typical thickness of hempcrete is between 3 and 16 inches, depending on application. Hempcrete is versatile, with 4 installation methods. It can be packed between forms in a process called cast in place, or made into blocks off-site. Hempcrete can be formed into panels and shipped to site to be installed by a crane, or wet spray applied into and around wall framing. HempStone has experience in all 4 installation methods. This simple chart illustrates the comparative differences between the 4 installation methods. Wet applied methods of cast in place and spray require more time to install and also have extended drying time requirements. Both wet apply methods are presently less expensive options, even though they require either skilled labor or specialty equipment at the job site. Block and panel installation methods, in contrast, are attractive for projects requiring simplicity and expedience in construction, but the challenge is that but require off-site manufacturing processes that are still in beta testing at this time in the United States. Hempcrete is a biocomposite made up of hemp as a rapidly renewable agricultural product. Lime is an abundant, naturally occurring mineral found commonly around the world. Both hemp and lime are recyclable and both store carbon in their structures. Lime has a pH of 12, making it an inhospitable place for mold, fungus, bacteria, and pests. Lime also renders hempcrete virtually fireproof. Hempcrete has characteristics of both insulation and thermal mass, providing an R2 static thermal resistance value while simultaneously storing latent heat and moisture. The moisture buffering capacity of hempcrete is its most compelling feature, passively regulating both temperature and humidity. The result is a consistent indoor temperature with healthy humidity levels. When not covered in a plaster, hempcrete absorbs sound. When finished in either lime or clay plasters, the natural finish absorbs airborne toxins and aromas, further enhancing air quality. Hempcrete is part of a building system, serving as the predominant mass of the wall and providing a solid substrate for natural plaster finishes. The Goshen Hemp House in Massachusetts was our first hempcrete collaboration. Built in 2020, this home costs less to build than its local conventional counterparts. In addition to lime and hemp plaster, this home utilized a full palette of complementary natural building materials throughout the structure. Village Carpentry served as contractor, designer, and client, creating the ultimate efficiency in collaboration, which certainly enhanced the affordability aspect of the build. Cast-in-place installations are notable for their serene environment, steady pace, and extended drying times. 3 years after moving in, the occupants note how rarely they use their cooling systems in the summer, instead relying on the natural buffering capacity of hempcrete insulation itself. Their heating loads are also markedly lower than conventional counterparts. Hempcrete is not airtight. Natural plasters are applied to the exposed faces of hempcrete to create an airtight layer. We conducted multiple blower door tests to evaluate the airflow rates of hempcrete and to quantify the value of plaster as an air barrier. The installation of one base coat of lime plaster decreased the airflow by nearly 8 times. Complete installation of plaster on both the interior and exterior surfaces reduced the airflow rates almost 12 times to a final value of 2 air changes per hour at 50 Pascal. Natural historic finishes of clay and lime share similar moisture buffering characteristics as hempcrete and are durable, long-lasting finishes. Hempcrete wall assemblies are vapor open and require finish materials that have vapor permeability ratings similar to hempcrete. Clay finishes are used inside, while lime is appropriate for both indoor and outdoor use. Natural plaster finishes can be pigmented at time of installation or later painted or washed with natural pigments to meet any decor. This dual structure collaboration at Wally Farms in Hillsdale, New York, is featured in the Healthy Material Lab's publication, Designing with Hemp and Lime. These buildings feature both block and spray installation methods and incorporate multiple other sustainable material initiatives. The design and construction team involved 6 key stakeholders with an appetite for experimentation. Wally Farms is an experimental farm committed to growing climate solutions. These small structures serve as short-term housing and are an experiment in climate-neutral housing solutions. My role was to coordinate the hempcrete and lime plaster knowledge and resources necessary to realize this vision. We collaborated with Coexist, a block manufacturer, and Americhandra, a spray installation company for these 2 structures. This was our first experience with the Arizi spray machine, which is best characterized as fast, loud, and messy. For the taller structure, we were able to take full advantage of the spray system and a mechanical lift for ease of construction. The interiors are finished with lime plaster with careful attention to air tightness detailing at all the transitions. Hempcrete, a structural frame, and natural earthen plasters combine to form a complete building system. The result is a healthy indoor environment in a natural setting. The Cape Cod Hemp House, also in the Healthy Materials Lab publication, Designing with Hemp Lime, is a 6,000 square foot home along the coastline of Massachusetts. Finished in 2022, this home strategically attempts to be a climate-ready solution in a changing climate. An exceptional team of building professionals collaborated on this project, bringing international expertise in hempcrete and lime plaster and a new spray machine. Hempcrete was installed throughout the thermal envelope using a high-volume spray machine from France called the Valkyrie. That's me on the roof installing the hempcrete. The hempcrete was finished in lime plaster inside and out, serving as the air barrier. On the exterior, a rain screen assembly was built so that the home's facade could match the building vernacular. Finished, this home blends seamlessly into its environment. After 4 years and 15 projects, we've learned a thing or two. So here's our biggest takeaways. Air tightness detailing matters. Bleeding edge projects typically cost more money and take longer. Project coordination is critical to success. Utilizing hempcrete expertise in the early design phase of consulting will save you money in the end. Design, from all our architects, design is the single most impactful factor in cost. And along with that, effective construction detailing is dependent on the installation method. Each technology and each jump in scale comes with both opportunities and challenges. We are in a rapidly evolving industry and our business must adapt accordingly. Some efficiencies are dependent on scale. At HempStone, we're committed to staying curious, flexible, and adaptive in both scale and technology in order to discover and refine the efficiencies of each of these different installation methods. Our goal is simple: disrupt the building industry with carbon-smart building materials any way we can. While we have a few obstacles to face, we also have a golden opportunity. Hempcrete's environmental and performance characteristics make hempcrete a true prince, allowing for the development of healthy and sustainable housing stock. In response to climate change, policy shifts are beginning to appear in the built environment. These carbon-based shifts will draw natural building materials ever more into conventional construction processes in the coming years. In the meantime, materials access is still a challenge. Hemp hurd is mostly supplied directly from processing centers, which are few and far between. What we really need are site-ready materials like block and panel systems in order to make hempcrete more accessible to a wider variety of project types, especially in dense urban areas like New York City. There is presently a cost premium for both materials and skilled labor. We need incentives and accessible funding mechanisms for carbon-smart construction companies to enter the development arena. By building in a sequentially progressive manner in order to stack the construction schedule, as typically done in housing developments, we can resolve many of the challenges to both cost and access through the use of scale. Speaking of scale, the Lower Sioux Indian community in southern Minnesota is doing something phenomenal. They have established a vertically integrated approach to hemp, first farming, then processing, and now building with their own hemp in a process that their visionary leader, Earl Pendleton, calls from seed to sovereignty. What's happening at the Lower Sioux Indian community, and quietly happening elsewhere in indigenous communities throughout North America, is the most ambitious and holistic thing happening in the hemp world today. My involvement has been quite simple in contrast. Engaged by the Lower Sioux Village Council, I provide hempcrete and lime plaster consulting and on-site training in support of a new hempcrete construction department within their community. The building behind us is a 16-foot square concession stand for the Lower Sioux powwow grounds. Constructed as a training structure, it provided the community with the knowledge required to commence building in earnest. They've since built a 4-bedroom single-family home using the same methodology. The Lower Sioux Construction Department has positioned themselves to be facile with all installation methods, drawing broadly on industry expertise to address their real need for jobs and housing. The Lower Sioux are presently finishing the lime plaster on this structure, an emergency housing duplex using both cast-in-place and spray methods. This month, they'll erect their first panelized hempcrete tiny home, and by next spring, they plan to be manufacturing hemp blocks for future buildings in a new 10,000 square foot dedicated space. The Lower Sioux Indian community is unified around the potential of the hemp plant to bring a new generation of economic security, and with that, sovereignty to their people. The efforts of the Lower Sioux Indian community reflect 3 independent processes in hemp, each process being its own unique industry: farming, processing, building. This small community of just 1,100 people living together on a few square miles of land is proving that a clear vision and a small group of dedicated people can do great things. I invite you to learn more about their successes through this 1-hour podcast. With roots firmly established at home, Earl Pendleton now seeks to support other First Nations communities in building their sovereignty through hemp. I'm honored to be invited to join in that effort. As I close, I want to bring your attention back to the Healthy Materials Lab publication, Designing with Hemp and Lime. This compendium wouldn't be possible without the visionary commitment of the building owners, the willingness of their design teams to share the knowledge, and their construction team's efforts to document their installation processes. It's been an honor to work alongside each of these caring and inspired teams. Thank you.
So this is so exciting because, years ago when we started this hemp research and we said we just need building materials that are not toxic and that do not emit carbon and that maybe heal the world, we thought this was like a dream, maybe a fantasy. Actually, we believed it could happen. But what you guys are all showing us now is that it's happening. And the way that each of you expressed your particular perspective feels like it's all happening. It's positive. It's just happening. It's already going, right? We can just do this tomorrow. But we know that that's not the case. I mean, what did you say? We're at the avant-garde, Tommy. We're at the avant-garde. We're not quite mainstream yet. And so,
or we're at the bleeding edge too, which
we're
is
at the
also
bleeding
the
edge.
scary part.
Yeah.
Possibly.
And so, here we have a room of architects and designers who are hopefully ready to implement. So the big question is, what's the hurdle? How do we make it mainstream? How do we bring this to mainstream? From the farm, we have to kill the weeds somehow, to production, into the building, affordably and scalably. So Jennifer, you addressed this a little bit, some of the hurdles in terms of time and in terms of efficiency and labor. But it would be great if
Yeah, if you could all reflect on each other's presentation, really, and what you're taking from the words of others, and how you see this system being created that it's going to be beneficial to all of us, I think. Is it possible? What are the roadblocks? What can we do today? What can't we do today? You know, what's possible? Because we're eager for this to happen today. So whatever you can say to help us understand, I think would be really helpful. Who wants to start?
Sure, I can kick it off because I'm thinking about how to knock these roadblocks down every day so that we can just break through to the other side. One is an awareness problem. There's really very little awareness that these products exist or are for sale. You won't believe how many people, exit through the gift shop, buy some insulation from us, but hadn't heard about us until that morning. And they're like, wow, I can't believe you guys existed. I Googled you and then I found out about this. I'm so excited. So awareness is a huge obstacle, but I view that as easily overcome, right? Good ideas can spread in our society. There's so much ways of communicating with each other and bringing good ideas to the forefront, doing amazing projects and showing them like that. And then the second one is cost is going to be a factor because people will do something that's more sustainable up until a point. If we can't be cost neutral for a one-to-one substitution in a lot of ways, then we're going to be fighting an uphill battle, not an impossible battle. Like we've been able to grow our sales at a relatively high cost, but it makes it harder on ourselves. And for our product, 50% of the cost is the hemp fiber itself. So I was just talking today, we got some longer fiber from a different processor. We wanted to see how it would run on our machines. He said, it cost 20% less, and we were able to run it when we mixed it in with some good fiber, and it ran pretty well. So, well, if we can use that fiber, we can bring our price down 10%, because that's half of our cost is all of that pound of hemp fiber. And truly, that's almost an arbitrarily set price at this point. There's so few farmers, there's so few processors, all that infrastructure is just beginning. We have no idea where the bottom of the market will be for price per pound of hemp fiber. So I think that is something that I always, in the back of my mind, I'm like, where is this going to get to? Once we get it scale, how cheap can we get this hemp fiber? How close can we get it grown to our facility? And then the last is performance, is we really need to make sure these materials perform well, not just in lab settings, but over the long time horizon of a building. Right? I think like whenever they open a new bridge, don't they have elephants walk over it to try and appease everyone's fears of how it's going to work? That's hard to do in buildings because you can't simulate year 80 of a building when you just made the wall today. But that's one of the things I was doing at Oak Ridge, right? We create wall assemblies. We put fiberglass on one side, hemp wool on another side, no vapor barrier, expose it to the rawest conditions you can. And so we put them in these chambers simulating different climate zones. And we want to see heat flux monitors inside the wall, temperature, humidity sensors. What's going on in there? Who's performing better? Where is the energy leaking? How do we get architects and builders to say, these products I feel confident in? They're going to perform how we expect them to. So those are the three things I think of most.
So let me follow that up with the farmer's perspective, who is not trying to reach the bottom of the floor for cost. Again, as a plant breeder, we hope that if we can double yields, then they can tolerate a lower price per pound. So that's where we need to go overall in the system. Some of the challenges that we're facing right now as I work with companies that are trying to source materials and recruit farmers is that most farmers are very diversified, right? So you're trying to break into their normal array of crops that they're growing and say, instead of doing that 50 acres of soybean, we want you to do 50 acres of hemp, right? So first of all, you have to be competitive with the current commodity price of soybeans and pay them enough that they're going to be profitable with those 50 acres of hemp. But right now we're at such an early phase and it's so risky for those farmers to grow hemp that you probably have to guarantee them a certain pay outcome at the end. And that's not a good incentive for them to perform well, right? If you're going to give them a guaranteed payment and they're not passionate about maximizing or optimizing their yield, it's not a great situation. So we need to break through that phase that we're in of guaranteeing farmers a certain amount of money no matter what their yield is, and get to a point where we have enough passionate farmers who want to make profit in this, and they got to have a market to sell it into. And once we have a good market, then farmers will easily adopt. They'll figure out how to control the weeds. They'll figure out how to get good yields. And then there will be performance-based profitability at the farm level. And once they're profitable, then you can start lowering their price maybe.
But Larry, so when you described the different, from one hemp plant, you can get fiber, hurd, and grain. Is that what you're saying?
And
so could we
and CBD if you want to.
and CBD, four possible products from one plant. So could we say that could be 4 times the market? The cash crop could be like 4 times if you 4 times a typical crop, for example. Is that this is totally naive. I have no idea about farming, but is that a possibility that hemp could actually give the farmer so much more profit than any other plant because of that?
Yeah, so there is the potential for that. And as we model the potential yields or revenue per acre, a dual purpose cultivation scenario, so grain and fiber, is the most profitable right now. But you have to have the equipment that is capable of harvesting grain from a 12-foot high plant. And there are only 2 of those machines in the US right now capable of doing that.
Do you have one?
We have one. And the fiber that you get out from that dual purpose scenario may not meet the specifications of quality for very demanding applications. So it's very hard to get the plant to produce the exact product that you want from multiple products with the exact specifications that you want. So we've bred high CBD plants that produce a lot of CBD and no grain and horrible fiber. We've bred fiber plants that produce incredible amounts of fiber but don't set seed at the end of the season because they're still growing and making fiber. So in plant breeding, you try to optimize for one product. We can imagine the dual purpose scenario, but each of those is going to be, is not going to be as good as the dedicated crop.
Just to pull on that a little bit more. So the quality of the fiber obviously, like when we visited Winona LaDuke, she's looking at fiber for textiles. She wants to make textile-based products. That's one quality of fiber. But here we have a hemp fiber insulation manufacturer. Do you need the same quality fiber? Could you use a less quality fiber for the insulation that then could also produce seeds, so then the farmers will have incentive to grow it instead of soybeans and make this whole thing happen faster?
If the price and performance is right, absolutely. So I think one of the other big challenges is dealing with natural products is there's a lot of variability. And when you're trying to meet certain R value specifications, you need fiber that's going to perform consistently. And so it probably needs to be from very similar genetics, grown under similar conditions, harvested and processed in the same way. So that is actually one thing we're leaning harder into is how do we grow for a way that produces the most insulating fiber possible? They talk about the lumen size of your fiber, like how much air can fit inside of it while not losing any of your dimensional stability that we love from hemp fiber. So that's where I expect a lot of the new advancement to come in is end users like us partnering with farm researchers like Larry saying like, okay, we got a bunch of fiber from this seed variety, throw it in the heat flow meter, see what the R value is. Okay, wasn't good, try this one. Okay, we'll try them at different densities. And it's that iteration and experimentation that'll get the best performance in the long run. So it comes down to the performance characteristics that need to be tested.
And I would say that that's true for building, but if you thought it was that he wanted the bottom dropped out, I really want the bottom dropped out on my cost, because I'm literally putting tons of material into each building, and I want it to be as cheap as possible. And if you want it cheap, you can't be super picky. So that is one of the challenges for us in the hempcrete world. We want to be able to get as much material as cheaply as possible. And luckily, we have not an exact specification. Although I have to say that when we're working with natural materials like hemp hurd of various sizes and we're mixing things on site, there's quite a bit of variability based on how much moisture we're putting into that mix and the climate around us. It is not a very specific, dialed in process. It's nuanced. It's almost like baking. And so it creates a different kind of challenge. It's a challenge of having an ability to work with a product differently than what we expect in our mainstream building process, where you open a product, it has instructions, you follow it specifically, you do it exactly the way that it's installed, and it works. You can plan it, you can predict it. Hempcrete is a little bit different, and it needs to have a little bit more understanding of how relationship with the material. It's a natural building product. And I have to give a lot of credit to Hempitecture. They started in the hempcrete world. It's at this point, it's still very new. It's challenging to be a hempcrete builder, and it's much easier to shift over to a product where you can give an industry things that they can expect, rather than work with a material that needs the sort of nuance that then has to be taught or handed down.
You know, but there's a kind of paradox here, right? Because natural materials aren't like petrochemically derived materials. They have this variability, and with this variability, they have these amazing attributes. Even the cost of these products, as we think about kind of the longevity of hemp lime, it has different qualities than, say, if you were using fiberglass bat insulation or something which has, you know, much less long-lived than hemp lime. So I think for me, as we think about this new industry, right, working with natural materials, there's also a different way I think that we as designers and architects have to think about this space and maybe develop new practices and new appreciations for the products, these new products that are being used. So I think that sometimes when we talk about uniformity, like we talked with Maddie and when we were in Boulder, and he was talking about the color of the bats, and he was saying there's all this variability in this hemp wool. You know, we see some is lighter, some is darker, and Jonsara and I were like, well, why would that be a problem? You know, because the performance may not be different. It's just the way you see it is different. So for me, there's a mindset kind of change that's happening in this space where we need to look at what we're doing, the products that we're using in a slightly different way. Yeah.
I know we're all so excited that we're talking so much in that,
Yeah.
you know, we're taking up a lot of time, but I'm looking at the front row, the biogenic house sections book that proposed that the future of building and cities will be all biogenic. Do you have any questions for this panel? Yes.
So one of the questions I have is exactly on this issue between a material that operates in a form of substitution to, which is more the bat, and whether you're taking a standard wall system or standard expectation, and you're saying instead of this, put this, and that therefore it can be more readily adopted, but there are also limitations in terms of the potential performance of the wall because it doesn't have the real quality that Jennifer is talking about in terms of its ability to deal with moisture. And I wonder whether or not there's a way to think about the scaling of the question of hemp lime and what the most expedient way to introduce that, or think about that on the substitution standpoint from a moisture standpoint, or on the other hand, is there a better wall system that you've imagined using the bat that if you didn't have to abide by just a substitution model, you'd imagine a whole different way of building. So it's really trying to get at, ways in which the substitution model can become transformative and the way in which a more handcrafted one becomes scalable to be able to keep those properties yet still address the kind of implications we need to do to make that scalable change.
Yeah, that's a great question. We always think of it as deep green or light green. And like hempcrete is a deep green because you really are taking out the drywall, the paint, you're taking out the siding, the vinyl. You're replacing all these elements of your wall assembly, but it's a huge commitment and undertaking you need to make from the very first day of your job site, or from before the first day, from the planning stage. Whereas our product is kind of a lighter green where you can sub in last second. You were going to go run to Lowe's and get fiberglass, but then you saw our product and you swapped it in. Great. So you do need options at every end of the spectrum. To answer the question is how do we revolutionize and have a more hempcrete type of revolution for our product is we are researching and developing, RPI is a partner. We actually recently got funding with the Department of Energy to create an insulated siding product. So we use the insulation insert of hemp wool paired with like a Duracip type panel so that you're able to just attach insulated siding to buildings as they are. So I look at our product as like almost a Lego building block that can be used in different applications to try and get at more than just a one-to-one substitution. Hopefully the plant panel continuous insulation is a step further towards that more severe rethinking of how a wall assembly should behave. But yeah, hempcrete has properties that really do make it a unique material for being able to replace so many different parts of the wall.
I appreciate that. That was very excellent, Tommy. I'm so big fan. Okay, so here's the dynamic with hempcrete. It's a system. Instead of having what we call the 7-layer dip where you have paint and drywall and a vapor barrier and then some sheathing, which is your racking resistance and framing, and then you have some more things on the outside depending on your facade, your outside. It's really just three things. It's a structural frame, it's the insulation, and then it is a finish. It's just potentially just three materials. But it takes a whole different mindset from the outset. When you're thinking in the early design conceptual phases, that's when you're really thinking about doing something really fundamentally different. And we happen to be in an industry that is very averse to change. We forget this because things are happening now faster than they've ever happened in the built environment, but it is reticent to change. It is risk averse as an industry. And so we really are going to have to rely on an injection of funding, and I'm expecting that it's going to happen at the affordable housing end of the spectrum rather than the high-end of the spectrum. And it's going to be a policy shift where people and governments are putting money into biogenic materials, and we are learning to then build in a different way. And until that happens, it's just going to be piecemeal.
We want that too. That's happening. So eager to connect these things because if we have the supply chain now, because it will be totally different. Like you're saying, we're risk averse, but it's totally different because the supply chain is now reliant on those farmers' incentives. We're completely reliant on the farmers wanting to plant hemp. And so, how do we incentivize those farmers through building? I mean, if everybody in this room said, we're going to build a multi-story hemp lime or hemp insulated building, is that enough incentive to get the farmers to plant the hemp?
Yeah, if there's a market and they're going to get paid, they will plant it.
So Is this a chicken or the egg thing? Like,
Yeah.
how do we get this thing going?
Do we have the right seeds? Do we have the seeds available for them to be able to start growing straight away, like in the spring 2024?
Yeah, so that is another barrier that we're trying to overcome because there was no domestic seed production of hemp. Early on, everyone was relying on imports, whether it was from Europe, from Poland, from France, from the Netherlands, from Italy, from Canada, or more recently from China. And those imports of seed, if you pay for a shipping container of seed and it's not properly handled, you go to plant your 2,000 acres of hemp and the seeds don't germinate. So that's, again, another huge risk. And unfortunately, I think there are folks out there who look for a lower price point and don't realize that they're taking a huge risk by paying that lower price point. So we are working actively. I work with a company called International Hemp that is exclusively producing seed domestically and certified seed. So we're getting there, but there's only so fast you can scale up that seed.
Can I ask one more question? How many acres of hemp does it require to build a building, hemp line building? Do we know?
I would usually say 3 to 4 unless you've got this really great high yield stuff and then it's only 1 or 2.
Right. So we need to, if we were just talking about New York State, we how many acres do we think that New York State can support of planting hemp, which would then tell us in the building industry how many hemp lime homes can we have next year in 2024?
Yeah, well, I can tell you that in 2017, we got a grant from New York State through Ag and Markets to essentially try to plant as much hemp acreage as we could. And we were very fortunate to get about 50,000 pounds of seed from a company in Canada. The governor expedited the import of that seed because this was before the 2018 Farm Bill. So we needed a DEA registration for that. And then we had to sign up farmers, and we worked with a couple of companies that aggregate farmers. And within a month, we had 24 farmers and 700 acres of hemp planted in New York State. And I personally rented a U-Haul truck and drove the seed around to those farms. But farmers will adopt it. They adopted it because they got a quite favorable per acre payment from New York State, regardless of how much yield they got. They didn't even have to harvest it. So I know that there are farmers out there that will plant it. And again, if they have a multi-year contract, they will figure out the best way to grow it. So that's what we need is companies that can give farmers a consistent multi-year contract. So again, they're not taking the risk on themselves.
So we need to subsidize this. Yeah.
I have a question, Larry, for you in those conversations. So besides price and the reliability of an end buyer, what else does a farmer bring up that makes them not, what questions do they ask before planting?
Yeah, so they want that crop to be successful. So they need to know how much fertilizer do they need to put on, what type of fertilizer, how are they going to control weeds? That's the big thing. What equipment are they going to need to harvest it? And because they can't afford to damage a piece of equipment on this crop that is very tough and very challenging to work with in many operations. And then what is the effect going to be the next year? So if they plant 50 acres to hemp, how is their subsequent crop going to perform? Is it going to be a weedy? Is all this hemp going to come up and they're going to have to control weeds? Well, I can tell you that it's very easy to kill hemp with herbicides. Hemp is very sensitive to just about every herbicide. That's why we don't have good herbicides to control the weeds, because just about every herbicide kills the hemp. Anecdotally, when we talked to farmers, for example, an onion farmer in Orange County said he planted about 25 acres of hemp, and the next year he had one of his best onion crops. So these are anecdotal, right? That's one example. We need a lot more examples to say, okay, if you plant hemp, the next crop you put in is probably may do better than what you expect. So it's, again, a system-wide approach. Farmers look at the entire system. How do they cultivate it? How do they harvest it? How is it going to impact their life year after year after year?
That's fantastic. We should open it up to the audience for
Two questions, so he says.
Hi, good evening. What's hemp's potential for urban or indoor farming? Is it a crop that can be grown indoor, or does it need to be grown outdoor in soil?
Yeah, for CBD, there's tremendous potential for growing hemp. For these applications that we're talking about here, the price of indoor cultivation and the scope of what you would have to do is way out of scale. But yeah, we can grow hemp pretty effectively indoors for CBD. Just again, another note, there's a bunch of hemp seed over there on the table. If you wanted to take some of that home and grow it, you would have to apply for a license to New York State Ag and Markets and pay $500 for that license and go get an FBI approved background check. So that's a major barrier to growing hemp. I can't just give away packets of our hemp seed here because you're not allowed to grow hemp until you get a license.
Thank you, everybody, for your work and your time here. I have a question about the lime component of hempcrete. Wondering, kind of given the fact that it needs to be mined and processed using lots of energy, how do you think about the embodied carbon of hempcrete overall as a material? And have you experimented with any lower embodied carbon binders?
Oh, I love this question. How long are we going to be here? I can't wait. So I love lime. It's my favorite building material of all. And it does have some real extractive qualities. So the way the lime cycle works is first you find the limestone and you dig it, and then you crush it and pulverize it, and then you heat it. And it's good 800-900 degrees Celsius. Y'all can check me on that. It's lower than Portland cement, but it still is pretty hot. And that then creates the process where it's quicklime, it gets hydrated enough that it's either in putty form or dry again, and then it's just kind of in stasis. And when you put water with lime, once it's in this stasis, it starts to return to limestone. So in that process, it's starting to absorb carbon dioxide from the environment. And a perfect lime cycle, now this is 100% pure lime, that's not necessarily what we're talking about here, but in a 100% pure lime cycle, that is a pure lime cycle. It returns to limestone, it absorbs all the carbon dioxide that was emitted in its heating. So that happens over days, weeks, months, years, decades. Like you will still see limestone absorbing carbon dioxide 60, 70, 80 years later. It is a slow process, but it does happen. So that's kind of a general sense of what's really happening with lime. Yes, it is extractive. Yes, it does take heat and energy. Yes, it does then reabsorb that carbon dioxide over time. We could get into a really long, wonderful debate about embodied carbon and the need to be thinking about embodied carbon at this point in time. And when you take hemp, which is storing carbon, more carbon than it actually weighs. I don't know how it does that, but it does. It's real weird. You could ask him. And then you mix it with lime, and a lime-based binder that's primarily a high calcium lime, And you've got a pretty awesome carbon sink, quite frankly, over time.
Well, we have Kaya Cool, who was the brains behind Wally Farms, which you saw. And she's here in the audience.
Key designer right there.
Hi. I wanted to, one thing I wanted to mention is we tried to calculate the transportation emissions for the hemp hurd and lime that the hemp hurd that we imported from France for Wally Farms. And so my question related to that is maybe to you, Tommy. You started also with distribution. For a room full of designers who are now maybe a little bit discouraged that there are still so many barriers. Is the alternative to create more demand, just, importing it, distribution? Oh, I should say, so the result of calculating this is that transportation emission is way less than the embodied carbon in the herd. So, and it's also less than it would have been if we had brought it from Idaho. So yeah, the question is, how do we move as architects this forward? Should we try to find the herd elsewhere if we can, or how can we help make these connections?
Yeah, it's always interesting opening up an EPD and seeing the assumptions in there. The one we need 12 months of manufacturing data to finish our life cycle analysis and get an EPD. But the one that the Quebec company did was using hemp that was also from France. 75% hemp fiber from France, 25% locally in Quebec. And it still had a low negative biogenic carbon uptake, and then the manufacturing process added some of that carbon back. So you are, swapping out sources, and for us, because the embodied carbon really is the name of the game, we look at everything from like, can we move this on electric trucks versus diesel trucks, or move it by rail? Or how do we have just the lowest energy use possible to get the same amount of output? Because that is what you're quantifying. And I would just say for architects then, open up the EPDs. They almost are like, they should be demystified because they're not as complicated as they look. And you open the table and you can see the assumptions. If you look at Rockwell's EPD, they make the assumption that every single piece of Rockwell you make never gets put in a landfill. It just gets put into a brand new building once you destroy the building. Now, I haven't been to too many demolition sites where they're preserving the rock wool to put in a new, but it does really good for their life cycle analysis. So, yeah, you kind of, there's going to be this huge clarification that goes on where hopefully we standardize all the assumptions so it's apples to apples. Until then, yeah, architects, we're kind of relying on you guys to be the shepherds of where the good materials are and who's making them.
Ooh, can I tag on to that? So architects in the room, how many of you had natural building information given to you during your education, your formal education? Anyone learn about natural building? Yes, 1, 2, 3, 4, 5, 6, 7, 8, ooh, 9, 10, 11, 12. Good job. Excellent. So the question was really like, what was your access and knowledge about natural building materials as you started your professional practice? And then my question going from that, like, what can architects do? Take on a new material in a new project. Be brave. I know it's really hard to be brave, but if we ever had a time that was more important than now to be brave, I don't know what it is. It's probably tomorrow. So, like, be brave today. Think of one material. You don't have to do bleeding edge projects. Remember, they're really expensive. They're more time consuming. That's not going to necessarily fit in your budget or your timeline. So pick one material, tackle it, enjoy it. Take a new material, tackle that on the next project. Learn about it, add it to your toolbox, and think about natural materials. Clay finishes, lime finishes, you can put that in any of your interiors. It will help your indoor air environment. It will increase your good feelings and what materials you're using, and it will help to change the industry because of your action today.
Touche. That's a great place to end. Thank you. So, thank you all for coming. Thank you all for coming. And we invite you on your way out to touch and feel all these hemp products, to have an extra glass of wine. I think there are still some there. And to sign up for our email list if you haven't done that already. There's QR codes over there for healthymaterialslab.org. Thanks again.